Hi ladies and gentlemen, this is Mr. Green and this is my video lesson for 6.3 for pre-cal. I'm glad you all are here and watching this. What we're looking at in pre-cal right at the moment is Unit 6, which deals with polar coordinates. And what we're looking at this time is 6.3, the polar coordinate complex numbers. Now, remember, we always have our due dates due in 28 days, but we're getting so close to the end of the semester. Semester is going to end, so you got to get these done before the semester ends. Don't worry about anything else as far as closing of things. Okay, polar coordinates. The one thing about polar coordinates is that complex numbers fit so well into them. Because remember, the rectangular coordinates fit into it too, where you had your x and your y and you were dealing with those. But polar coordinates, when you're dealing with that imaginary number, it's it's kind of difficult to envision that in rectangular coordinates. So if you do it in polar coordinates, it actually helps a little bit sometimes, okay? So remember, when you're dealing with polar coordinates, you're dealing with a vector, and a vector is not a number, so you can't just do regular math with it. Okay, the big deal there is if you've got complex numbers, you have to use FOIL. You have to multiply the first, the inner, the outer, and the last when you're multiplying two complex numbers together. That's a big deal. You got to make certain you're understanding how to do that because it will result in another imaginary number, another complex number. But you've got to be very, very careful with it, okay? So make certain you're following that type of rule. But other than that, polar coordinates for complex numbers can either be written as r theta or as r cosine theta, comma r sine theta. Remember, that's the trigonometric form of a complex number. Now, the big thing in this whole lesson that you need to make certain you understand how to do is how to convert it from complex numbers and get the modulus and the argument. Okay, the modulus is that r. Okay, right here. That's the magnitude of the vector. That's where you're taking the square root of a squared plus b squared. So if you've got a complex number, a is the real part, b is the complex part, the imaginary part. You just a squared plus b squared, add them together, take square root of it, and that's r. And then to find the theta, you have b over a. Well, here's your b, here's your a, and you just take that and you take the arctangent, I'm sorry, of it, and that'll tell you what the degree measurement is. Okay. Now you have to be careful. A lot of times they like to do it in radians, so make certain your calculator is set to radians, and the number will always be between 0 and 2 pi, and that's typically in radians too. Now, the conversion between polar and rectangular coordinates, if you're in polar and you want to go to rectangular, you just take r cosine theta, and that's what your a is going to be. And you take b is going to be equal to r sine theta. And you just take those, and it's really easy to convert from polar to rectangular coordinates. But if you're taking from rectangular to polar, that's where you take the a squared plus b squared to get r squared, and you take b over a and arctan of it, and that'll tell you what theta is. Those are the big deals that are going on in this lesson. I hope you understand all this. If you have questions about it, go ahead and come to tutoring. I'm going to be out this week, but if you come to tutoring, I will try to take care of you as best I can. Okay? I will talk to you later.